Hello, my name is Sachin Tobene. Currently, I'm a student of ICBD campus, and I'm here to present you the presentation I did on my module of Foundation of Computer. And here you can explore the everything I put into my work on this presentation. And let us go to the next slide. This is the table of content, and here we have the topics we are gonna see on the next slides. First, we have internal components of CPU, function of a CPU, how computer hardware components work together, different types of storage media and their uses, data representation in computer systems, how encryption can be used to represent data, images and sounds, how compression can aid the storage of data, images or sounds, the purpose of logic gates, the purpose of different types of computer network, the hardware, software, and transmission with media used in computer networks, range of a World Wide Web technologies, the purpose of different types of computer network topologies. And to the next slide, we have the first topic on the we saw on the table of content. A computer processor of a computer processor, often called the central processing unit (CPU), is the brain of a computer. It is a hardware component that executes instructions and performs calculations necessary to run programs and operates the computer systems. There are three main parts of CPU: arithmetic logic unit, control unit, immediate access store. And the definitions of the three parts here given are: this is the arithmetic logic unit. This is the part of CPU carries out the arithmetic and logical operations are performed, such as addition, subtraction, and or etc. Control unit. It acts as the brain of the CPU since it controls the manages the execution of instruction. It determines the sequence of operation, directs the flow of data, and ensures proper coordination among different components. Immediate access store (IAS). This is the part where the data and programs that the CPU needs are stored. The next slide, we have the functions of CPU. The CPU process instruction it receives in the process of decoding data. In processing this data, the CPU performs four basic steps. And the steps are: fetch is the process operation which receives the instructions from program memory from a system's RAM. Decode is where the instruction is converted to understand which other parts of the CPU are needed to continue the operation. Execute is where the operation is performed. Each part of the CPU that is needed is activated to carry out the instruction. Store is where the CPU must give feedback after executing an instruction. The next topic is how the computer hardware components work together. Computer hardware components work together through a variety of mechanisms, including interfaces, binding mechanisms, and communication between components. Interfaces provide connection and joins for fixed joint operations. A binding mechanism fix hardware in place to make installation and maintenance easier. Communication components communicate with each other through a command bus or circuit board. The different types of storage medias and their uses. The storage media refers to physical media or hardware used to store digital or electronic data. The optical media, data storage media distribution, archiving and backup. Magnetic media, audio and video recording, data transfer and communication. Data storage, hard disk drive, primary storage in computers, media storage, data backup and archiving. Flash drives, data storage, backup and storage, bootable drives. And we have two pictures for these examples we read on the slide just now. The hard disk and a flash drive. The next slide, we have data representation in computer systems. Data representation in computer systems is fundamental understanding how computers process and store information. As its core, computer use binary digits or bits to represent data. A bit can have one of two values, 0 or 1. Data is organized and represented in different levels of abstraction in system. First, binary representation refers to the method of expressing numbers, characters, or other data using only two symbols, 0 and 1. Numeric data refers to data that represents numerical values or quantities. Data structure refers to the way of organizing and storing data in a computer so that it can be accessed and manipulated efficiently. Files and formats refer to the way data is organized and stored on a computer. And we have how data can be represented via encryption. Data encryption translates data into another form of code so that only people with access to secret key, formally called a decryption key or a password, can read it. Encrypted data is commonly referred to as ciphertext, while unencrypted data is called plaintext. Currently, encryption is one of the most popular and effective data security methods used by organizations. Two main types of data encryption exist: asymmetric encryption, also known as public key encryption, and symmetric encryption. The next slide is how images and sound are represented in computer systems. Image representations. Images in a digital system are composed of tiny colored squares termed pixel, a picture elements. Each pixel represents a distinct color component of the image. The color and intensity of each pixel are defined by a bit pattern. In a common color image, every pixel is commonly represented using 24 bits, 8 bits each for red, green, and blue RGB channels. In a grayscale image, each pixel could be described with a lower bit depth, often 8 bits. The quality of an image can be defined by its resolution, number of pixels, and color depth, bits per pixel. Higher these values, the better the image is fiddled at the cost of file life. Sound representation. Digital sound are created from analog sound through process term sampling. Includes recording the amplitude of a sound wave at irregular intervals. The sample rate, number of samples per second, and bit depth, its bits per sample, determine the quality and fidelity of digital sound. Common bit depths are 8, 16, or 24 bits per sample, and a standard sample rate for CD quality audio is 44 kilohertz, meaning 44,100 samples per second. We have next how compression can aid the storage of data, images, or sound. Compression in computer science refers to reducing the size of data to save storage space or increase the speed of transmission. There are primarily two types of compression: lossless and lossy. Lossless compression is a method of data compression where the original data can be perfectly reconstructed from the compressed data. Examples of lossless compression algorithms include PNG, ZIP, and RAR. Lossy compression is a data encoding method that employs inexact approximations to represent content. It compressed data by discarding some of it. The process highlights the more important data units while dropping the less consecutional ones. Example of lossy compression algorithms include MP3, HPEG, and MPEG. The purpose of logic gates. What are logic gates? A logic gate is a device that acts as a building block for digital. They perform basic logical functions that are fundamental to digital circuits. What is the purpose of logical gates? They are used to perform basic arithmetic operations and logical operations. They can also be used to perform Boolean algebraic operations such as AND, OR, NOT, NAND, and NOR. And here we have a picture of a logic gate circuit. And the next topic is the purpose of different types of networks. Here we have 5 different types of networks. We more have we got more than 5, but I put only 5, and here we can see what is the purpose of those. Local area network LAN. A LAN is used for connecting devices within a limited geographic area such as home, office, or school. It allows devices to share resources like Files, printers, and internet connections. LANs are typically fast and reliable. Personal area network. PAN. A PAN is a design for personal use, typically connecting devices like smartphones, tablets, laptops, and wearable devices within a small area. A few meters, it is mainly used for file sharing, syncing devices, and as accessing peripherals like printers or headphones. Metropolitan area network. MAN. A MAN covers a larger geographic area than a LAN, but smaller than a WAN. Typically within a city or a large campus, it is often used by business or government buildings or universities to connect multiple LANs within a city or region. Wide area network WAN. A WAN spans a large geographical area, often covering cities, countries, or continents. It is used to connect multiple LANs, allowing communication and resource sharing across distant locations. The internet itself is the largest example of a WAN. Virtual Private Network (VPN). A VPN provides a secure encrypted connection over a less secure network like the internet. It allows users to access private networks remotely while maintaining privacy and security. VPNs are commonly used by business and individuals for secure remote access. The hardware, software, and transmitted media used in computer networks. Hardware includes devices like NICs, routers, switches, cables, and access points that physically connect devices and enable communication. Software governs the functioning of the network, including operating system protocols and management tools. Transmitting media is the media that to which data travels, such as cables or wireless signals, ensuring that data can flow between devices in the network. And range of worldwide technologies. We have a picture with the technology of topologies here. The range of worldwide technologies covers everything from the different development of websites and applications using HTML, CSS, JavaScript, and various frameworks to the infrastructure. Oh, excuse me, this is the wrong one. Infrastructure that supports them include it also includes the protocols, HTTP, webs that make the communications possible. The security technologies SSL to ensure safety and the tools for web design and representative. These technologies combine to make the World Wide Web function secure and user-friendly across different regions. The perks of different types of computer network over. This is the last topic we in the presentation right now. Bus topology. Purpose. Bus topology connects all devices to a single central campus. The bus. It was one of the earliest network topologies used in local area networks. Stop topology. Purpose. In a stop topology, all devices are connected to a central device such as a hub or a switch. This is the most widely used topology in modern LANs. Ring topology. In ring topology, devices are connected in a closed loop or ring with data traveling in one direction. Unidirectional or both directional, bidirectional. Mesh topology. Mesh topology involves connecting each device directly to every other device in the network, creating a highly redundant and fault-tolerant structure. Tree topology. We also call it hierarchical topology. A tree topology is a combination of star and bus topologies. It is hierarchical with groups of star networks connected to a central bus like backbone. And thank you everyone. Uh, watching me watching the presentation I did, and that's all. Thank you. Bye bye.